Okay, so I think the most interesting question is it worth it to purchase the Sam's Club membership? So let's think about our cost versus our gain here. It costs $45 to join, and she gets 5% cash back on her purchases. So let's let X stand for the amount of money that she's earned for her cash back. If we earn our cost of $45 back plus more, then I'd say that this membership is probably worth purchasing. Ignoring the fact that maybe Sam's Club purchases save you money because the prices are cheaper, but we're just strictly going to think about, do we earn our $45 back? How much does it take? So how much we earn back is 5% of the money that we spend. So let's call the money that we spend y, and I'm going to go ahead and change this to 0.05 instead of 5%. So if I want to make sure that I earn at least $45 back, let's see how much money I have to spend to earn $45 back. So if I solve this equation, 45 divided by 5% gives us that you'd need to spend $900 in order to earn $45 cash back. So I'd say it's worth it if you know that you'll spend more than $900 in a year at Sam's Club. Let's think about a little bit of geometry. This one's kind of open-ended. We're told we have a right cylinder and a cone with the same radius and volume, and we want to know what possible height each of them could have. Okay, so the cylinder and cone have the same volume, so I'm going to go ahead and take my volume formulas and set them equal to each other. Notice that I did H1 and H2 to stand for my two heights. That's because I don't know that my heights are equal. I do, however, know that they have the same radius, so I could divide both sides by my radius squared and simplify this a little bit, and also divide both sides by pi and simplify. So I will have equal volumes if I have height 1 equal to 1/3 times height 2, where height 1 is my height of my cylinder and height 2 is the height of my cone. Or if you don't like the fraction, you could say that 3 times height 1 is the same thing as height 2. Let's think about one concrete possibility here. Say if height 1, so the height of my cylinder is 3 centimeters, then I know that height 2 is 3 times that. So if the height of my cylinder is 3, then the height of my cone would have to be 9 centimeters. Or if the height of my cylinder is 2 centimeters, then the height of my cone to have the same volume would have to be 6 centimeters. So we can generalize here. If the radiuses are equal, the cylinder and cone will have the same volume as long as the cone's height is 3 times the cylinder's. Or you could flip it around and say is the cylinder's height is 1/3 of the cone's. Okay, so we've got basically two squares in this problem. It says the length of each side of a square is increased by 5 centimeters, and then it tells you some information about the perimeter. I like to draw pictures, so my original square, I'm going to call its side lengths just x, and then it says that I'm increasing the sides of this square by 5 centimeters, which means I am adding 5 centimeters to whatever my original length was. So I'm going to label these sides as x plus 5. Other fact that I know is the perimeter of this new square is 50 centimeters more than 3 times the length of my original square, and I labeled that length as x. We want to find the dimensions of the original square. Okay, so let's use what we know about our perimeter. So our perimeter is supposed to be, for our new square that I just boxed in blue there, 50 centimeters more than 3 times the length of my original square. So I'll do 3x plus 50. The perimeter of my new square is 4 side lengths of x plus 5, so I'm just going to multiply 4 times x plus 5 instead of adding it up 4 times. And then if I solve that equation, 4x, subtracted 3x from both sides, and then I'm going to subtract 20 from both sides, I end up with x equals 30. Make sure you answer the question. We are looking for the dimensions of the original square, which x was the dimension that I needed. So 30 centimeters by 30 centimeters.